Malik? Where did you put my services? I can't find my Kubernetes services anywhere. I thought it would be really simple to find where my services ran, just as simply as it is with pods and finding where they run. Whenever somebody talks about a service, you think about this application that runs somewhere that provides a service, and you hit it. And a lot of times that's how Kubernetes services are drawn, and the fact is this just isn't true. And if you look for them, you'll never find them. And today I'm going to show you just where they are and why you'll never find them.
3, 2, 1, 0.
The No Channel.
All right, guys. If you haven't already guessed, today's episode is on Kubernetes services. Now, why did I say, where are my services? Because you can't really find them if you are just looking for them. They don't really exist. And yet, they exist everywhere. This is the conundrum of the Kubernetes services. And while you don't really need to know this to just use a Kubernetes service, I find it really helpful to understand these types of things. And so I wanted to dig into them with you and give you a brief overview on Kubernetes services, how to create one, how to use one, and most importantly, where the crap do they run? All right, so let's first start off with why you need a Kubernetes service. If you're new to Kubernetes networking, I strongly suggest that you check out this video I made on Kubernetes networking. That's going to cover everything from a Kubernetes service to an ingress controller to a service mesh. And I strongly recommend that you check that out and start to understand the entire from pod to user workflow. But this video is just about the Kubernetes service. Now, why do you need a Kubernetes service? And the reason you need a Kubernetes service is your Kubernetes cluster has many different nodes usually has many different nodes that your pod could run on. And it could run on any one of them. Not only that, if it fails or dies or you expand to have a second node, how do you know where its IP address is? How do you route traffic to it? And this is what a service solves. Now, you don't have to use a service just for routing traffic to pods. There's other uses for it. But for right now, this is the standard case and the one we're going to be covering. This is why you use a service. A service allows you to route traffic to these pods, and you don't have to worry about where they're running. And in fact, it's all handled for you. So if they die and stand up on a new node, your Kubernetes service will be updated automatically, and anything that's using that will be updated if it's using the service. So this is what a service does. Now, how do we create one? Like always, we use a little bit of YAML. This is what a Kubernetes service looks like, and it's actually quite simple. Here we have an app selector. This is just letting us select which app by label we want to route traffic to. And this is super powerful, and you can do a lot of stuff with this. We're not going to get into that, but this is how you do it. So we're going to send this to my app. And then all you're going to notice is that we have a protocol and some ports. And this is all you need to create your service. Well, and a service name, of course. And all you have to do is kubectl and apply this, and now your cluster has this service. And it's routing to my app. All right, so now that we've got how to create a service and how to route traffic to a pod or group of pods, this could be one or more pods, let's talk about where this runs. Now, as most of you probably know, there are 4 types of services. You have your cluster IP, which is a internal accessible by the cluster or things inside the cluster only. You have your node port, which is accessible outside of the cluster by exposing it on a set port on each and every single node. You have your load balancer, which is a special type of cluster IP and node port. They can use either one that a cloud uses, where it has a load balancer that sits outside the cluster that routes traffic inside to either a cluster IP or a node port type of service. And then you have your external name, which is really used just to return a CNAME for some service, and is a lot of the times used when you're trying to expose an external resource in a Kubernetes style. So let's say you already have an external database that you don't want to migrate into Kubernetes, and you'd like to expose it to everything inside of Kubernetes using a Kubernetes service, because that's the standard practice. That's what that's for. And there is different use cases and different configurations, but we're not going to get into that. All right, we have these 4 types of services, and we have a loose idea of what they do and how they work. But where is your services? Where are your node port services? Where's your cluster IP services? Where do they run? When you create a new one, can you find where it runs? And the answer is, it not only runs everywhere, it runs nowhere. There is no new pod that handles requests for it. There is nothing new that runs on the control plane. So where does it run? The answer to this is kube-proxy. Kube-proxy is actually a daemon set that runs on every single one of your nodes. This is why it runs everywhere. But when you create a new service, you do not stand up a new kube-proxy. It's just a daemon set. There's only one on every single node. And kube-proxy itself can run in 3 different modes. Now, be careful. This is different from the different types of services that it provides. It runs in several different modes of how it proxies your request. The first is user space mode. User space mode, it actually listens to a port, and when it gets requests on that port, it proxies it to that service. And so that time, kube-proxy is actually acting as a proxy. But this is actually the only one that it acts as a proxy in. And because of this, it actually is probably a fairly slow, and you probably shouldn't, it's not the preferred way to run your cluster, because it runs in user space. And this means that there is this whole translation from kernel space to user space, and it's not the most performant method of doing it. The other 2 are when it runs in IP tables and IPVS mode. In these cases, kube-proxy doesn't actually proxy the requests. It just updates the IP tables or IPVS on every single one of your nodes. And in this case, then each of your nodes becomes a proxy, because each one of your nodes knows about all of the services. Because every single time the kube-proxy watches the control plane, and as soon as there's a new service, it updates your IP tables or your virtual networks and adds one. Well, adds a virtual network or updates the IP tables. And now, when your machine gets a request, it knows what service you're talking about. And both of them look very much like this, except switch IP tables for IPVS, but you get the point. It's the same type of thing. And in this way, kube-proxy isn't actually proxying your requests. It's just updating each node so that every single node can proxy your request. So when you make a request on port 31,000, that is mapped to a proxy, or that is mapped to a service that is well known to this node. And this is how all of the proxying and all of the services in Kubernetes work. So now you know the basics for how Kubernetes services work, where they run, and how Kubernetes handles it. I hope that you guys found this short and fun and entertaining, and hopefully, most of all, a little bit of educational. And that is how Kubernetes proxies work at a very high level. If you'd like to go more in detail on how any one of these works, IP tables versus IPVS, go ahead and let me know in the comments below. If you're wanting to get more into how to use services in not the standard way, we could also go into that. Leave me a comment below, because there's a whole plethora of ways, like running headless services. If you're running stateless sets, that's actually super useful. So there's a lot of unique ways you can use these. So if you want to learn more about that, leave me a comment in the comments below. If you'd like to join the community, there is a Discord and a Twitter. Please feel free to tweet at me or join the Discord and let me know things that you'd like to see videos on, or just talk with other people in the community and get to know one another. If you found this video helpful, please like and subscribe. If you'd like to stick around and see more educational content. If you did not like this video and you thought it was the worst, please stop. Leave me a comment on how I could make this video better for you. And go ahead and subscribe to this channel anyways. Stick around and see if these videos get any better for science. Follow me on Twitter and, yeah, stay a part of the thing. Stay a part of the thing.